Hello everyone. Today we are going to review some of the organisms that live among the coral reefs in the oceans around the world. The predator, the primary producer, the primary consumer, the decomposer, and the intermediate consumer. So, what are these five choices that we have today? We have the predator as the black-tip reef shark. The primary producer is the zooxanthellae. Primary consumer is the Atlantic blue tang, the decomposer is queen conch, and the intermediate consumer is Caribbean lobster. So first we'll touch off on the black-tip reef shark. These are among some of the smaller sharks in their family. However, they are arguably the biggest predator that roams the coral reefs. They have been categorized as near threatened on the IUCN Red List. The black-tip reef shark is a heterotrophic animal. It typically eats the consumers due to its carnivorous nature. And this takes us to the primary consumer, the Atlantic blue tang. Atlantic blue tang are heterotrophic herbivores. These fish will only eat algae and are typically eaten by the black-tip reef shark. Blue tang are differing in color from light blue to dark blue. They generally have golden blue highlights on their fins as well. Blue tangs are typically found in areas such as the Gulf of Mexico, southern Brazil, Belize, Ascension Island, and Ambergris Caye. Zooxanthellae are reef-building algae that lives in coral polyps. These are autotrophs that take in sunlight to gain energy and build reefs. Corals and algae have a mutual relationship, as corals give algae a protected environment and compounds needed for photosynthesis. Algae produce oxygen and help remove waste for the corals. The relationship between the two is very tight as they recycle nutrients. About 90% of organic material photosynthetically produced by zooxanthellae is transferred to the host tissue. Zooxanthellae is also responsible for the beautiful colors that many of the corals have. Queen conch are a mollusk that eats algae. They are a heterotrophic herbivore who belongs to some of the same taxonomic groups as clams, oysters, octopi, and squid. They are normally found in the Florida Keys at a high number, and due to a collapse in conch fisheries, it is now illegal to fish for conch in Florida. Caribbean lobsters are mainly foragers of the reefs and one of the omnivorous heterotrophs that are also slightly nocturnal. These crustaceans hide under shelves, caves, ledges, and in crevices during the day. However, during night and twilight hours, these lobsters hunt for snails, crabs, decaying organic matter, and plants. These species are vulnerable to overfishing, which is why, in many cases, it is illegal to fish for these crustaceans. So, the food web or chain in this instance is really very simple. Predatory organisms such as the black-tip reef shark is at the top of this chain. Below this is the herbivore known as the Atlantic blue tang. However, blue tang only eats algae, in which case would be zooxanthellae. This, along with queen conch, essentially places the two at equal positions, and with the Caribbean lobster not having eaten many things other than, things such as plants and algae and other things like that, also sort of places them at the equal area as the blue tang and the queen conch. And finally, zooxanthellae is at the bottom of the chain, where they receive sunlight and produce photosynthesis. Some abiotic factors that affect the reefs below are both beneficial and harmful to the reefs. Sunlight is one such abiotic factor that is very helpful to the ecosystem below the waters. When there is a good temperature, it is helpful to the reef. However, abiotic stressors would involve cold temperatures as well as high acidity and high salinity. This essentially makes the area unlivable for many organisms, including the coral polyps themselves. That's why you do not see any. That's why you don't see any coral reefs in the Atlantic or in the Arctic Ocean or in high acidic areas. Geological events such as underwater earthquakes and geysers can affect a reef massively. If a reef has been built right on top of a divergent boundary, the reef can be split in half and cause the temperature to rise rapidly. A chemical effect to the reef would be a rise in salinity or acidity. This could make the reef uninhabitable to organisms that live here. A major physical change would be the formation of a dead zone. A dead zone occurs when there is a surplus in nutrients such as nitrogen and phosphorus. The surplus is what causes an algal bloom. This causes algae and other plants to grow rapidly. This rapid growth of these organisms blocks sunlight from entering the reef. Algae will take all the oxygen from the area below them and deoxygenate the water, thus creating a dead zone. Dead zones are known across the world, and while they are naturally occurring, they are also a product of human activity, mostly from agricultural runoff. We have dead zones. We have a very big dead zone in the Gulf of Mexico along the coast of Texas and Louisiana, Florida, things like that, as well as a naturally occurring dead zone at the southern end of the Black Sea near Ukraine. So, although algal blooms do happen, they do die quickly. When the algal bloom dies, it sinks to the bottom and is decomposed by bacteria. This does allow the sunlight and oxygen to roam freely through this once to be called dead zone, but because of the amount of dead algae there is and the amount of bacteria that is needed to decompose, most of the bacteria takes up about 90% of the oxygen that roams through this area, so it is essentially still unlivable for any organisms to live in. Organisms that are caught in dead zones typically die if they cannot escape. Fish tend to be able to get away just on their own. So, I hope you enjoyed this presentation, and I hope you have a good year. Yeah, thank you.